patty paper, if you had a compass, highlighters, pencil, straight edge, etc. And my computer is on like hyperdrive right now, so part of this video would just be worth it just to like double time and just create what I've created here, okay? So here we go. In order to create perpendicular bisectors, I'm going to use the compass method. So I'm going to use an arc that goes with a compass that's spread out more than halfway across from one line segment. Like it's definitely over what I can see as the middle. And then after that, I'm going to create an arc. If you want to take a shortcut, the shortcut could be I'm going to draw 1, 2, and 3 full circles. This is absolutely a lesson or an activity that could be drawn, come on now, could be drawn or done, like rip the paper out of your book. And I want you to notice something. I'm going to show it and then I'm going to let you guys understand. I don't need all of this. I don't need all of this like out here. So I'm going to erase. I know I created it for you because I see students do this all the time. I'm going to show you, you don't need all of this circle out here. We only need where the circles cross. So if the circles aren't crossing and they're not near a place where they cross, just get rid of it. Don't even draw it. Okay, now connect like within this oval right here. Again, apologies for the document camera being glitchy. In this oval right here, they cross. The oval has 2 places where the circles cross. So we're going to draw a line through those 2 places. Do the same thing for this oval right here. I mean, it's not technically an oval, but it's close enough that it makes sense for words. For this line right here, draw the line that's called a perpendicular bisector through the places where those 2 ovals cross. There are 3 sides to the triangle, so there must be 3 lines that cross. And look at where they all cross, highlight it, because this is the circumcenter. C-I-R-C-U-M-C-E-N-T-E-R. Circumcenter. All 3 lines cross in the same spot. Okay, with less explanation and more just doing, maybe you just skip forward in the video. We're going to create that for all of these. Construct a point of concurrency using the perpendicular bisectors of a triangle by constructing the 3 perpendicular bisectors of each triangle. So I'm going to do the obtuse one next. Not even going to change the size of my compass, and I'm also going to go silent as I create them. I'm going to come back on for right now. So, hey, turn the sound on. I'm talking to you. And that's this one. I noticed that my compass isn't quite like past the midpoint of this 3rd side of the triangle. So I have to open up the compass, spinning the wheel on this professional one, or sliding the compass span, like plastic part, to be wider, then drawing my 2 arcs. All 3 perpendicular bisectors, talking again, all 3 perpendicular bisectors come together at that location. That makes that the circumcenter of the triangle. Go to the next one, right triangle. See if I can zoom in, reset my window. Ah, missed it. Ignoring like the little mishap that I had right there. In a right triangle, this is a special key notification. They all cross and actually are on that hypotenuse of the right triangle. So that will always happen. In a right triangle, the perpendicular bisectors will land on the center, on that hypotenuse. Okay, last one. Again, skip forward. This is just really practice. So I'm just going to show you that I've done it for all three of them. You should practice this as well. Watch, rewatch, see, the video and repeat. And then once you can do this without any direction of anyone else, you've got the skill down. Okay, so practice it again. I'm going to go back on silent and just create the perpendicular bisectors for the equilateral triangle. Back in, hello, sound on. In an equilateral triangle, all three perpendicular bisectors actually go through the vertices of the triangle. So that happens in a right triangle one time, one of them goes through the vertex of the triangle, but in an equilateral triangle, all three perpendicular bisectors will cross the other side. Now, this is something I want you to notice. I can take my compass, I can center the compass on that circumcenter. I can open the compass up so that it touches one of the corners of the triangle. Doesn't matter which corner I pick, because when I draw this, if I draw this right, little off up in the top there, but it will go through all three corners. Try it for the next one. Here we go. When it's constructed properly, and we're human, we make little mistakes here, but it's pretty close, pretty spot on. Your circle will actually, centered on the circumcenter, will touch all three corners of the triangle. Okay, just going to prove that for all of these. Center and span. Get it in the paper, and you are able to put all three corners of a circle on, or all three corners of a triangle on that circle. Next up. Circumcenter helps find the center of the triangle so that you can put a circle around the triangle. There's a phrase at the bottom of this page. Let's finish it out and then move you forward. So let's go. Zoom in, zoom out. Make a conjecture about the location of the intersection of all three perpendicular bisectors. Is the intersection located inside, outside, or on the triangle? Okay. The three perpendicular bisectors. I'm just going to write. You just see what I'm writing. Skip forward after I've written a bunch. The three perpendicular bisectors of any triangle will intersect at a single point. For an acute triangle, the circumcenter is going to be inside the triangle. For obtuse, it's going to be outside the triangle. And for a right triangle, the circumcenter will be on the triangle's edge. Thank you for watching page 265. See you in the next video.